All right, let's start talking about the bell work. On number 1, the directions say simplify. I promise you, when you get to the test on Thursday, the most important thing you need to do is if you see a fraction show up, you need to know what's happening between them, because that determines your very next step. What is happening between these two fractions? Division. When you see division happening between two fractions, what does that mean? Yes, we're going to keep the first fraction. We're going to change the operation. And we're going to flip the second fraction. So I'm going to keep my first one, 16xy cubed over 9x to the 5th. I'm going to change that division into multiplication, and then we're going to flip our second fraction. When I flip the second fraction, I don't change any numbers, I don't change any symbols, I don't change anything about it. I just flip the sides. So up on top, I'm going to have 3x squared. Down on the bottom, I have 4x to the negative 2 y squared. So now that we've done our keep, change, flip, and I know that we multiply fractions straight across, I know I basically have just one fraction going on here. There's something in that second denominator, the one that we flipped, that's catching my attention. Something that hopefully they've been asking you to look out for since Algebra 1. What do you guys see in that second denominator that's catching my attention?
X squared.
X squared, only down in the denominator, it's not x squared, it's x to the
Second power.
negative second power. Yes. That's what it is that caught my attention. When you see a negative power, where does it want to go? In this case, it wants to go up to the top. If it was on the top, it would, like wherever it is, it's not happy there, it wants to go to the other side. So I'm going to flip it and bring it around here, but only that piece. So 16xy cubed. We said this is turning into one fraction, so that's getting multiplied to 3x squared, and then we just brought up this x squared. When I bring it up to the top, it becomes positive. Over 9x to the 5th, turning it into one fraction because we're multiplying it together, 4 and my y squared. What do you guys think I should do next? We got a lot going on here, don't we? Let's pick one thing to focus on. Where should my attention go next? Greg, what do you think? Where should my attention go next? What should we do to this? Zay, do you want to offer an assist? Absolutely, I can get you a Band-Aid. What looks like a mess that would be really nice if we could clean up. Yeah. Plus, we got all kinds of letters going on, right? No, go ahead. So let's look. I've got like an X right here. Do you guys see X's anywhere else? Where else? Yeah, I have x squared and another x squared right here. I'm just going to think about that off to the side. So I have x that's being multiplied to x squared. That's being multiplied to another x squared. What's the power on this one? 1. What can I do with this idea right here to clean it up? X times x squared times x squared. How could I rewrite that? X to the 5th power, yes. When I have the same base over and over, x and x and x, and they're all being multiplied together and they have powers on them, we can combine those together, and I can just write that whole idea as x to the 5th. All right, so I've got 16, and you told me this will all combine together to give me x to the 5th, and I have y to the 3rd. And that's then getting multiplied. I still have that 3 over there, right? So I have the 16. We combined our x's, y to the 3rd, and the 3. Down on the bottom, I have 9x to the 5th times 4y squared. Do you guys see anything that we might be able to reduce or cancel? Anything that's the same between the top and the bottom? X to the 5th. Here and here, since they're exactly the same, I can cancel them out. Anything else that you see that we might try that same reducing idea with? The y's. I have y to the 3rd and y squared. Y to the 3rd over y squared. What do I do with the powers here? Subtract them. I'm going to subtract that power of 2. Whatever's on the bottom is what I'm subtracting from the top. If what's on the bottom is bigger, then I go the other way. This is going to give me y to what power? Just y to the 1st power, right? So I'm just going to write that as a y. All right, so I have 16 times y times 3 over what? 9 times what? 9 times 4. I could multiply the 16 and the 3 together, and then I could multiply the 9 and the 4 together. But at the end, I'm going to have to do what to my fraction? Reduce it. I'm going to stop right here and see if I can reduce. Can you guys think of another way that I might be able to write a 16 that would let me see something that would cancel? 16 is what times what? 4 times 4. So I could rewrite that 16 as 4 times 4 times y times 3 all over. Should I maybe rewrite anything in the denominator that'll let me see things that'll cancel? 3 times 3 for that 9, right? 3 times 3 times 4. I'm not rewriting the 4, even though I could. Why am I not rewriting the 4? I see a 4 up in my numerator. I don't need to rewrite it because I already see something that it's going to cancel with. One of these 4s will cancel with this 4 down here. Can I do that with anything else? 3 and 3. So what's still left in my numerator then? 4y is left in my numerator, and 3 is left in my denominator. Beautiful. Can that reduce any more than that? Can anything go into 4 that also goes into 3? Then that's fully reduced. That's why I stopped and wrote the 16 as 4 times 4, and I wrote the 9 as 3 times 3, because it's a whole lot easier for me to reduce it there than if I multiply the 16 and the 3 together and I get 48, and I multiply the 9 and the 4 together and I get 36. I can still reduce it, but once the numbers get bigger and bigger, it gets more difficult. I've asked this question on a couple different types of problems, but I'm going to ask it here. Is this a polynomial? How do we know? Yes. When I look down in the denominator, there are no variables left at all. right. That finishes off our first problem. Let's go look at number 2. What do they want me to do in number 2? Factor. What's the first thing we always look for when we factor? GCF. Do we have a GCF here? Is there anything that will evenly go into all 3 parts? Nope. I'm going to need to make my x. Will I be allowed to use my shortcut after I make my x? Why not? A is not 1. So no shortcut this time. All right, so I need 2 numbers that multiply to give me the product of A and C. What's my A value and what's my C value? I have 2 and what? 2 and 4, and when I multiply those together, I get what? Oh, come on, guys. I know it's Tuesday. I know it's rainy. Yep. 2 times 4 gives me 8. What's my B value? Because that goes down here. -9. So I need to think up 2 numbers that when I multiply them together, I get a positive 8. But when I take those same 2 numbers and I add them, I get -9. What kinds of things multiply to 8? 2 times 4. Is there any way I can take a 2 and a 4 and get to 9? So what else multiplies to 8? 1 and 8. Can you think of how we can use a 1 and an 8 and get to 9? -1 and -8. I need it to multiply to give me a positive, so they have to be the same. Since my B value is negative, the bigger number has to be negative, but since I need it to multiply to give me a positive, they both have to be negative. So these are the numbers that I'm going to put inside my area model. A goes here, so that's my 2x squared. C goes here, so that's my 4. And then those 2 numbers that we just found, and we have to put x's back on them. So -1x, -8x. All we need to do now is side to side, up and down, and we'll get this thing factored. Which way do you guys want to go first? Side to side first or up and down first? Up and down, sounds good. 2x squared, -8x. What can I take out of both of them? 2x. What about -1x and 4? -1. I like that you said 1. Tell me why it's negative. Yep. We always have to pull that sign out with it. All right, we went up and down. We got 2x minus 1, so that's one of my factors. That becomes part of my final answer. Then we're going to go side to side. 2x squared and -1x. Just an x. What about -8x and 4? -4. Why not -8? 8 doesn't go into 4. That's absolutely correct. It has to go into both of them. 8 goes into itself, but it doesn't go into the other number. So I have to get smaller. So we tried 4 next. 4 goes into both of them. So x minus 4. That is fully factored, and I am done. Nice work on that bell work today. So we're going to spend the rest of the class time today getting ready for your test on Thursday. Yesterday I passed out the paper reviews. If you don't have a copy, you are welcome to come up and grab another one. Although I think I hit most people when I was going around during bell work time. If you're one of those people that likes to have a second copy because you want to work through it again, please come up and grab one. You're more than welcome to do that. You do get a cheat sheet this time, just like last time. Same exact rules as before. It's one-sided, so on this side of, it's like an orange colored sheet this time. Only thing that can go on here is what? The only thing you can put on this side, just your name. Other side, you can put anything you want. Any example problems, anything. I'm going to go ahead and pass these out. You guys have time to work on them in class today. You'll have time in class tomorrow, although tomorrow we do have a shortened class period. Tomorrow is career speaker day, so I only have you guys for half an hour instead of 45 minutes tomorrow. Third period? So we have the career speaker, and I just got the schedule. I got the bell schedule. I don't know the speakers themselves and how all that works yet. I believe you'll go to your third period class, and then your third period teacher will have the information for you. I had to scroll through my emails and check that again, but that is to the best of my knowledge right now. A couple things I want to make you guys aware of. First thing is an extra credit opportunity. I hardly ever am able to offer these. There is a short 5-question multiple choice, similar to yesterday, but it's not the same questions. It's called in-class review. It's on Canvas. If you complete that anytime before the test on Thursday, I will give you extra credit. The review itself, on Thursday, you're either going to turn the paper copy into me, or there's a Canvas version of it. All the questions are exactly the same. You can choose to do the Canvas version of it instead if you'd like. The Canvas version is 100% automatically graded. So if you work some things out on paper and you want to know if you're right, between now and when my answer key goes up towards the end of the school day today, you are welcome to hop into that Canvas review, type your answer in, and click submit to see if you're correct. So you guys have the rest of class to work on your review and your cheat sheet. You have the rest of class to work on your review and on your cheat sheet. You need to be working either on paper to get ready for the test, or you can be on Canvas. But if you're on your phone, I will be coming around to see that you are working on the Canvas review. If you guys have any questions, I'm more than happy to help. You can move around and work with whoever you'd like. One of the things that I would recommend having on your cheat sheet, in addition to example problems, is some kind of things to get your brain going. Like the questions that I asked you guys as we're working through problems, those can be really helpful when you're looking at questions yourself on the test. What kind of operation is in between my fractions? If it's addition or subtraction, do I have a common denominator? If I don't have a common denominator, I need to factor. Putting those types of reminders for yourself in words next to an example problem can be really, really powerful.